topic name is permutations and combinations. Friends, permutations means arrangements of things, and combination means selection of selection of things. Let us say, guys, there are n things to be arranged. There are n things, and from the n things you are arranging r things. So arrangement of r things out of n things will happen n things will happen in NPR ways. Similarly, uh, combinations are selections selections of r things out of n things will happen in NCR ways. And NCR is expanded like this: is NCR is equal to n factorial by n minus r factorial into r factorial. And NPR is expanded like this: n factorial by n minus r factorial. That's it. This is about NPR. And if you multiply r factorial to NPR, that will convert to NCR, independent. So this is NPR and this is NCR, and we will be using NPR for permutations. Permutations are nothing but arrangements, and we will be using NCR for combinations. Combinations are nothing but your selections. Now, friends, let us go one by one. Let us say you want to write an exam. We want to write an exam which has uh, four papers in it. Okay, four papers, namely quants, reasoning, English, and GK. So you are having a exam. You have to give an exam which has four papers in it. It is actually one set of exam with four papers in it. So in how many ways we can attempt this exam is? In how many ways we can attempt that exam? Nothing but it is your number of ways of arranging the exam. See, in one way you can arrange quant, reasoning, English, and GK. You can write in this way. This is the one of the way I am talking about. In another way, you can write reasoning, quant, English, GK. In another way, you can write GK, quant, reasoning, English. Like this, guys, how many ways are possible? That is the question. In how many ways this exam can be written? In how many ways this exam is going to be written? Guys, as I am facing some difficulty here in word file, I will take you to the notepad and explain over it. Okay, friends, we are here. We are trying to find how many ways calls, English, reasoning, and GK exam is going to be attempted, right? So, guys, to find how many ways, let us take first one, two, three, four blank ones, and the first blank can be filled with. It can be written with quants, English, reasoning, or GK. So, first blank can be filled with four ways, guys. Okay, coming to the next blank, as one of the among these four, one will be filled in the first place, so remaining will be three. So three ways will be there to fill the second blank. Similarly, two ways will be there to fill it, and one way will be there to fill it. So we are going to have number of ways to attend the exam. Number of ways to attend the exam is 4 into 3 into 2 into 1. Nothing but 4 factorial ways. Nothing but 24 ways. So this forms in English, reasoning and GK exam can be written in 24 ways. This is one example. This is the example for permutation. This is the example for permutation. Okay, that is arrangement. We are just arranging the papers here. Okay. Now let us go and write one more example. Yes, one more example. Let us say we are having a word read, and I want to rearrange the letters of this word. Rearrange letters of this word of the word. Then in how many ways it can be possible? In how many ways it can be possible? That is the question. So guys, if you want to rearrange the letters of the word read, and in how many ways the arrangement can be possible is to write it. Again, we will be taking four blank spaces because there are one, two, three, four. Four letters are there. So one, two, three, four. Four blanks we are taking this. And as you know, first blank can be filled with four. Okay, ways, that is R can be filled with E can be filled with A can be filled, D can be filled, right? And next one will filled with three because one letter will be filled over there in the first one. Next one will be filled with two. Next one will be filled with one. Because we are, see, let's say first one is filled with R, this is filled with A, this is filled with E, this is filled with D. When first one is filled with R, to fill this second blank, guys, we are having three letters A, E, D. That three options are there. So let us say A is filled over here, and to fill the third blank, we are having two options, either A or D can be filled. Let us say E is filled here, and to fill last option, we left with only D. That is only one option. So here also, guys, number of rearrangements would be 4 factorial. 4 factorial is nothing but 24. So this is without repetition. Whenever repetition is not given, then we are going to do this. When letters are repeated, we will have to. That depends upon the question whether we have to consider repetition in it or not. We will see one of the example. Okay, friends, let us see one more word, CLASS, class. We are having the word class now, and we would like to rearrange the letters of the word without repetition. We are not allowing repetition here, okay? So when we are not allowing repetition, what happens is, how many letters are there? One, two, three, four, five. Five letters are there, so take five blanks. One, two, three, four, five. Okay, and guys, we can say the letters will be arranged in 5 factorial ways usually, because there are 5 blanks, so 5 ways, 4 ways, 3 ways, 2 ways, 1 ways. 5 factorial ways, but they are asking us without repetition. So in this 5 factorial, you will be having a situation where 2 s's are written over here. So if you want to remove the repetition, like, you will have to divide the given with 2 factorial, because there are 2 s are there. So we will be dividing with 2 factorial. Guys, when we are having a point when there are n things are there, out of which p things are alike, q things are alike, and r things are alike, the number of arrangements will be n factorial by p factorial into q factorial into r factorial, where p are alike, p are similar, q things are alike, q things are similar, and r things are alike, r things are similar. So by following this property, the arrangement of the word class will be having obviously 5 factorial, that is n factorial. There are 5 letters are there, so 5 factorial. From there, two s's are there, that is s and s are there, that is two s are alike things. So we are dividing it with the alike things. And we know 5 factorial is 120, 2 factorial is 2, so we are going to have 60 number of arrangements of this word class. We are going to have 60 number of arrangements of this word class. I hope you understood this problem. We will work out questions in the PDF file. Now let us take one more question from combinations. Combinations. Okay, let us say there are people. Let us say there are 10 male and 5 female members, and we want to choose 3 males and 2 females in a team. We want a 5 members team means in that we want 3 males and 2 females. So how we are going to choose is number of ways of selecting number of ways of selecting 3 male and 2 females is, guys, we want 3 male from 10 males. So we will be using 10C3, that is choosing of 3 males from the 10 males, and means multiplication, and we will be choosing 2 females from 5 females, and that can be done in 5C2 ways. Okay friends, excuse me. You are choosing 2 females from 5 females, that can be done in 5C2 ways. Now friends, upon expanding NCR, NCR can be written like this: NCR is equal to n factorial by n minus r factorial into r factorial. This is NCR expansion is. So we will be saying 10 factorial by 10 minus 3 factorial, 7 factorial into 3 factorial. And here 5 factorial by 5 minus 2 factorial, 3 factorial into 2 factorial. So upon expanding this and cancelling, what we get is, okay, let us do it manually. 10 into 9 into 8 into 7 factorial by 7 factorial into 3 into 2 into 1, that is 3 factorial. 7 factorial we cancel into 5 factorial. 5 into 4 into 3 factorial by 3 factorial into 2 into 1. 3 factorial cancel. 2 times will go. So, and here it is 2, 4 times it will go. 3 times it will go. It is 3 into 4, 12. 12 into, over here 10 is there. 120, one more 10 is there. So there are 1200 ways to select them, guys. There are 1200 ways to select them. So this is how we use our combination technique to find number of combinations or selections from the as per the given conditions. Okay, friends. Now what we will do is we will go to word file and we will solve some questions over there. Okay, friends. The first question in permutations and combinations. In how many ways can people be seated in a row? It's very simple ways as we have discussed there. We can directly write like this: in a row, 5 people. To make them sit, we need 5 places: 1, 2, 3, 4, 5. And 5 people can, in first place, can be filled with 5 ways. Anyone can come and sit over here. Let us say one fellow A occupied the first place, then remaining 4 people are there, and those 4 people have the chances to sit here. 3, 2, 1. So this is 5 factorial. 5 into 4 into 3 into 2 into 1. This is nothing but 5 2 into 1, nothing but 5 factorial. 120 ways. Okay, going to the next question. In how many ways can the word assassin be arranged? Okay, guys, here as how we did in class problem, here we have to eliminate the repeated tenses. So rearrangement of word assassin will be A S S A S S I N. We are having this word assassin. You can see four times. S is repeated four times. A is repeated one time. Sorry, two times. A is repeated two times. Assassin. That's it. Then no more repetition. I is repeated one time and N is repeated one time. But there are one, two, three, four, five, six, seven, 8. There are 8 letters guys. As per the previous explanation, out of n things, p things are alive, then we will be doing like this: n factorial by p factorial into q factorial into r factorial. So we will be following this rule. So totally there are 8 things. So 8 factorial by s is repeated 4 times, that is 4 factorial, and a is repeated 2 times, that is 2 factorial. So this many arrangements can be done for the word assassin. And if you expand it, 8 factorial, 7, 8, 7, 6, 5 into 4 factorial by 4 factorial into 2 factorial. 4 factorial will cancel, 2 4s. This is 30 into 28 days. 40, 56, 560, 5688. This many ways the word assassin can be rearranged. It is just calculation and applying the logic. Okay, and then guys, let us go to next question. From 10 students, a team of 4 is to be formed. In how many ways? It's easy. Just now, as how we done, they are saying there are 10 students. We want 4 people team. So can be done in 10C4 ways. 10C4 can be written as 10 into 9 into 8 into 7 by 4 into 3 into 2 into 1. This many ways. So 4 into 2, 8 can be cancelled. 3 times can be cancelled. 2 10 ways. There are 10 ways to select 4 students out of 10 students. Okay, there are 10 ways to select it. Let us go to next question, friends. In how many ways can 6 people sit around a circular table? Okay, guys, for circular table, we want to arrange the 6 people ways. So, guys, in circular arrangements, what happens is circular arrangements. What happens is if you want to arrange n people in the arrangement, that will happen in n minus 1 factorial ways. This is number of ways in which arrangement can be done this. So there are 6 people, they want to sit around the circular table, then the number of ways of arranging the number of ways will be 6 minus 1 factorial ways, that is 5 factorial, that is 120 ways. 5 factorial and 120 ways. Okay. Remember, arrangement of n things in a circular phase in a circular table will be having n minus 1 factorial ways. That is the catch point. Going to the next question. There are 10 people in the room. How many handshakes will be there if each person shakes hands with every other person exactly once? Thus, we are having a formula for handshake, guys. It's a direct formula, and the link is also very easy. The logic is also very easy. Handshake. There is handshake formula. Guys, let us say there are n people, and if we want to give one handshake, guys, we need 2 people. So we will be choosing 2 people out of the n people for a handshake. In this case, we'll be having NC2 handshakes. That is 10 C2 handshakes altogether. We'll be having 10 C2 handshakes. So 10 into 9 by 2 into 1. This is also 10 C2 expansion is 45 handshakes are possible. So in that 45 handshakes are possible. Excuse me. Let us go to one more question, friends. From a group of 8 men and 6 women, a team of 5 is to be formed such that at least 3 women are included. In how many ways this can be done? Friends, let's answer this question. There are 8 men and 6 women, but we want 5 people team. 5 people team. Condition is 3 women are included. At least 3 women. Guys, at least 3 women means we will be having 3 women, 2 men to form a 5 members team. We will be having 4 women, 1 man, 5 members team. We will be having 5 women, 0 men. This is also 5 members team. So we will be calculating probabilities and we will be adding them. Sorry, we will be calculating competitions and we will be adding them. Guys, to get 3 women, what we do is 6C3, that is we are selecting 3 women out of 6 women into 8C2, we are selecting 2 men out of 8 men plus 4 men. 6C4 into 8C1 plus 6C5 into 6C5 into 8C0. 0 men we are selecting out of 8 men. 0 men we are selecting out of 8 men, right? Okay. You can do the calculations here. 63 means 6 into 5 into 4 by 3 into 2. That is 6 will cancel. Into 8 means 8 into 7 by 2. 2 into 4. Plus 64 means 6 into 5 into 4 into 3 by 3 by 5, 6 by 4 into 3 into 2. 8C means 8C1 means 8 plus 6C5 means 6C5 means 6, 8C0 means 1 means 6 factorial 6 minus 5 factorial. It's further going on. So here we are having 5 into 4 20, 4 into 7 20. That is 20 into 28 we are having 20 into 28 making it 40 56 56 560 plus 4 4 3 3 will cancel 2 3 times will be 3 into 5 15 plus oh, 8 by 2 15 that is multiplied with 8 15 multiplied with 8 is 126 plus 6. So we are having 500 600 686 686 500 600 686. Yes, this is the number of weeks of revenue left. It is at least condition means when at least condition comes you have to follow this way. Going to the next question. In how many ways can 6 boys and 4 girls be seated in a row such that no 2 girls sit together? No 2 girls sit together. Okay, conditional permutation friends. You can see over here. We are having 6 boys and 4 girls, and the condition is no 2 girls sit together. So what I do is first let us arrange the boys B1, B2. Here is a space, here is a space. Here is a space B3, B4, B5, B6. So six balls are arranged and calculate number of spaces guys. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So there are 7 empty spaces where 4 girls can be seated. I'll take this question to the notepad. Guys, there are 4 girls, 6 boys, right? So let us arrange them. Boys B1, B2, B3, B4, B5, B6. Calculate the spaces 1, space 2, space 3, space 4, space 5, space 6, space 7. There are empty spaces. There are 7 empty spaces where 4 girls can sit. 4 girls can sit. If they are sitting in these 7 empty spaces, guys, 7 empty spaces, they can be they can start in any place, right? Let us say girl 1 is sitting here, girl 2 is sitting here, then they are not coming side by side, then our condition will be satisfied. So this can be done in 7p4 ways, and boys internally can be arranged in 6 factorial ways because boys positions can be changed ways. Totally 6 places are there. 6 places can be arranged in 6 factorial ways. So as per the given condition, we can say 6 factorial, that is 120 into 6, that is 720. 720 that multiplied with 7p4, 7 factorial by 7 minus 4, 3 factorial. This many ways will be there. 3 factorial is nothing but 6, 6 can be cancelled. So you will be having 120 into 7 factorial. Guys, you can say 5 factorial is 120, which is multiplied with 6, it will become 6 factorial, which is multiplied with 7, it will become 7 factorial. So your final value will be 120 into 7 into 6 into 120. This many number of arrangements will be there as per the given condition. Okay friends, let us go to one more question. I hope you understood. Let us go to one more question. The student has to answer 5 out of 8 questions in an exam, including at least 2 compulsory questions. In how many ways can it be done? Okay friends, I think it is better to take this question to the notepad as we are having. Okay friends, so the question has come here. Let us answer the question. The student has to answer 5 out of 8 questions. So totally there are 8 questions are there. In that he has to answer 5 questions guys. He has to answer 5 questions, okay? Including including 2 compulsory questions. In how many ways can it be done? Guys, in the 5 questions he has to give 2 compulsory questions. 2 compulsory questions, right? So 2 compulsory questions will be answered in one way. And how many remaining questions are there? How many remaining questions? 3 questions are there. And for these 3 questions, from 8 questions, he can choose any of the questions. Okay. So totally he has to answer 5 questions. Let us say total 8 questions are there. In that 2 compulsory questions are done. So remaining are 6 questions. From these six questions, we are going to choose three questions here. So two questions can be done in one way, and from six questions, three questions will be chosen 63 ways. It will be chosen 63 ways. So we are choosing three questions over here, and because choosing is the option, because we have the option to choose here. Okay, two compulsory questions are there. After writing two compulsory questions, we are having choices. So remaining six questions will be there. From the remaining six questions, we are having three choices. Three questions of our choice can be attempted. So we are choosing the questions here. And the answer for this one is 6 into 5 into 4 divided by and expanding 63. That is 3 into 2 into 1. 6 can be cancelled. In 20 ways they can write the exam. Okay, let us go to one more question please. I'll take this question. This question says in how many different ways can the word be rearranged the letters of the word management such that all vowels come together. Okay, condition is here. There is condition is all vowels come together. Okay. So guys the word is M A N G L A N A G E N E N T management. Management. Okay. Guys, first count the vowels. A, two A's are there. Vowels. E, one E is there. Two E's are there. Two E's are there. I, is there any I? No I. O, no O. U, no U. Yes. So these are vowels. A, two A's are there and two E's are there. This come together means always you have to consider the as a black, and the black is representing as, and we will be considering that black as one black. Okay, whenever you are arranging somewhere here, that black will come, that A double E will come. Next time it may come in the second place, next time it may come in the first place. That is rearrangement will be there. Guys, and this black can be rearranged in this many ways, guys. Arrangement, rearrangement of black can be done in how many letters are there? One, two, three, four. Four letters are there. That is 4 factorial by 2 factorial into 2 factorial. Because two are similar, two articles are similar. That is, two A's are there. So P alike, two alike here. So we can say 4 factorial by 2 factorial and two alike. Two E's are alike. So we have to divide with the 2 factorial. And this will be coming as 4 factorial, 4 into 3 into 2 factorial by 2 factorial into 2 factorial. This 2 factorial will be cancelled. 2 into 2 times it will go. This will be done in 6 ways. So vowels together will be done in 6 ways. Now coming to the consonants. How many consonants are there? 1, 2, 3, 4, 5, 6 consonants are there. Friends, here 6 consonants and one block of vowels will become 7 letters now here. So these 7 can be 4, 5, 6, 7. The 7 can be arranged in 7 factorial ways. The 7 can be arranged in 7 factorial ways. Okay, internally vowels can be at 7 factorial ways. And is there any repetition in consonants? M is there, M, yes, two M's are there. Okay, in consonants we are having repetitions. You can see one M, two M's are there. Okay, N, two N's are there, two N's are there, N, N, G. How many G's are there? Only one G is there, only one T is there, right? Hmm. So these are repetition. We have to divide with repetition, that is 2 factorial into 2 factorial multiplied with 6 ways, that is internal arguments of consonants, vowels. This can be done in 7 factorial. Okay, 2 factorial means 2, 3 times it will go. 7 factorial means 7 into 6 into 5 into 5 into 4 factorial by into 3 by 2. 2 3 times. 21 into 5 will be 21 into 5 into 4 factorial means 24 into 3. So this many ways this word is going to be arranged. The management is going to be arranged. I hope you understood. Let us go to one more question. In how many ways can 7 persons be seated around a circular table if two particular persons must not sit together? Okay. For this case, two particular persons must not sit together. What we do is, okay, I think I have to take this question to. Friends, in how many ways 7 persons? See, in circular, it's a circular element. Circular 7 persons can be arranged in 7 persons can be arranged in 7 minus 1 factorial ways. That is 6 factorial ways. 5 factorial means 120, 6 factorial means 720 ways. Okay. The condition is two particular persons must not sit together. So must sit together can be written as all arrangements all arrangements minus sit together arrangements. Excuse me. Sit together is equal to two persons sit together is equal to totally 7 people are there. So 5 people will be one sector, 5 people will be one, and these two people F1 and F2 will be sitting together. Let us consider that as a black. This will be internally done in 2 factorial ways, and there are 5 people. 5 people plus one black, 6 factorial into 2 factorial. This many ways those sit together is possible. So all elements are 720. From there 6 factorial into 2 factorial into 2 factorial. Okay. Next, this is a circular element. 5 plus 1, 6 people are there. 6 people will be drawn in 5, arranged in 5 factorial ways, right? And 5 factorial ways. So this is 2 factorial. So here you will have 5 factorial into 2 factorial, not this 2 factorial. Okay, this is the mistake. So 720 ways minus 5 factorial into 2 factorial. This many ways. 720, 5 factorial means 120, double is 240. This many ways they are going to arrange in this. Okay. Now let's see some questions from this page. I hope you understood. And don't you asking the class, I clearly explain your first probability. We know probability means Probability. This probability is defined as it is a ratio of number of favorable outcomes number of favorable outcomes by total number of outcomes. Total number of outcomes. Total number of outcomes is also called by sample space. Yes, we have coins, unbiased coins. We have unbiased coins. We have pack of cards. We'll be picking cards from the pack of cards. We have dice to roll. We have dice, unbiased dice is also dice to roll, and we will be doing them and finding the probability sets. Probability basic definition is number of variable outcomes by total number of outcomes. Okay, what we do is we will take coins, next to dice, next to cards, and we will discuss the questions. Later we go to a PPT and answer the questions. Okay, friends. Let us take a coin. What we do is we'll take just one coin and we'll toss it. Okay, then sample space, that is total outcomes will be guys, when one coin is tossed, either we have head or we will have tail. This is the total outcome guys. And if I ask you what is the probability of getting one head as the output, probability by definition uh, favorable outcomes by total outcomes, right? Okay. Okay guys, favorable outcomes comes by total outcomes. Our sample space is equal to C. One head choice. In the total outcome, there is only one choice. So one choice by total two choices. 1/2. So probability of getting one tail is equal to you can see there is only one choice for tail, that is favorable outcomes is 1 and total outcomes is 2. So probability of getting one tail is also 1/2. And guys, we have a wonderful property, probability of happening of an event, probability of happening of an event plus probability of not happening of the not happening of the event is always equal to 1 and probability of happening of an event is always equal to less than or equal to 1. These are the two properties we are having guys. So if I apply this probability of happening of head plus head plus probability of not happening of the head. Not happening of the head is nothing but tail, implies probability of happening of the head is 1/2, not happening of the head, that is tail, is 1/2, that is equal to 1. So that is the probability guys. Probability property. Always probability lies between or less than or equal to 1. This is when one coin is tossed, friends. And when 2 coins, 3 coins are tossed, we will be using combination technique to save our calculation part guys, or to avoid the confusion. Let us say 2 coins are tossed. Let us say three unbiased coins are tossed. Friends, when 2 coins are tossed, sample space is 2 square, that is 4. And when 3 coins are tossed, the sample space is 2 cube, that is 8. That is 2 power n. N is number of coins. Number of coins, that is sample space. Okay. Now if I ask you what is the probability of getting one head as the output, you can say let us use combination technique guys. You want one head from 2 coins. So that will be taken in 2C1 is, that is favorable outcomes guys, and divided by sample space, that is 4. 2C1 is nothing but 2 by 4, that is 1/2. Similarly, if I want probability of getting two tails, if you want two tails, you will have to choose two tails out of the 2 coins. So I am choosing two tails out of the two coins. So favorable outcome will become 2c2 divided by 4. 2c2 is nothing but 1 divided by 4. Similarly, if I want two heads, guys, two heads will be, you will have to choose two heads out of the two coins. That will happen in 2c2 is divided by 4. That is favorable outcomes by total number of outcomes, right? That nothing but sample space. 2c2 is 1 by 4, right? Yes. And if I want probability of getting zero tails means you will have to choose zero tails out of two coins divided by 4. 2c0 is nothing but 1, that is also 1 by 4. Coming to the three coins, my friends, coming to the three coins, let us say I want the probability of getting two hits as the output. You are saying that you are choosing two hits out of the three coins. So that will be done in 3C2 ways. You are choosing two heads out of the three coins. So favorable outcomes will be 3C2 divided by sample space 8. 3C2 value will be 1 guys, that is 1 by 8. So 3C2 is nothing but 3 factorial by 3 minus 2 factorial. That is 1 factorial into 2 factorial, right? 3 factorial by 3 minus 2 1 factorial into 2 factorial. 3C, 2 values 3, not 1. This is 3. Okay. Friends, similarly, if you want three tails, P of three tails, probability of three tails will be, you are choosing three tails out of the three times, so that will be done in 3C 3 ways divided by 8 ways. 3C3 is nothing but 1, so you are going to have 1 by 8 as the probability of getting three tails. Similarly, if you want to find probability of getting four tails, that will be choosing the four tails out of three coins by 8. Guys, 3C4 value is 0, that is not possible divided by 8. So total probability is 0 because when you are tossing three coins or when you are tossing a single unbiased coin three times, there is no question of getting four tails. There is no question of getting four tails. How can we get a tail, extra tail guys when three coins are tossed? Well, that is right. The probability of getting four tails is equal to 0. Okay, friends. This is about choosing the kinds. You may be getting a question like this. Okay, let us take one question. When three coins are tossed, they may ask you, when three coins are tossed, what is the probability of getting at least at least one head and the output? So guys, if you want to see, there is sample space will be 8 here because three coins are tossed. At least one head means probability of getting at least one head plus probability of getting at least two heads plus probability of getting at least three heads. This thing you will have to do because there will be no four heads, so remaining probability will be 0 0 and it goes like that. Probability of getting one head is choosing one head out of three counts, that is 3C1 by 8, plus probability of getting two heads is choosing two heads out of three counts, that will happen in 3C2 ways by 8, plus probability of getting three heads is 3C3, choosing three heads out of three counts, that will happen in 3C3 ways by 8. So we will be having 3C1 is nothing but 3 by 8, 3C2 is nothing but 3 by 8, 3C3 is nothing but 1 by 8. Altogether you are going to have 7 by 8. 7 by 8. So probability of getting at least one head is equal to one head is equal to 7 by 8. And this question can also be answered like this: probability of getting at least one head is equal to total probability minus probability of getting no head, no head. So we know total probability is nothing but 1, probability of any event is nothing but 1, minus probability of no head means either you will have to choose all three tails or you will have to choose zero heads. So let us choose zero heads first. Out of the three coins, I am choosing zero heads. No heads means zero head divided by 8. 3C0 is nothing but 1 minus 1 by 8. This is 1 minus 1 by 8. That is nothing but 7 by 8. So whenever at least question comes, guys, you have to use either this formula, that is probability of at least one head is equal to total minus probability of no head, or you will have to individually calculate as how we calculated before. I hope friends you have understood this example. Okay, let us go to the dice rolling. Let us go to dice. Okay, friends, we are having unbiased dice. Dice has six surfaces. Six surfaces. By having the numbers 1, 2, 3, 4, 5, 6. Okay, and when a dice is rolled, sample space will be single dice rolled. Sample space will be 6 dice. When two dice are rolled, sample space will be 6 into 6. That is 36. When three dice are rolled, sample space will be 6 into 6 into 16. That is 2 and 6 dice. You may be getting questions up to dice, 3 dice also in an examination. So you must prepare, you must be ready for that. If I ask you when a single dice is rolled, if I ask you a question, uh, okay, when a single dice is rolled, guys, if I ask you what is the probability of getting even number as the output, so probability of getting even number. First we have to calculate favorable. First we have to calculate favorable outcomes, guys. Okay, guys, we'll continue the topic. Actually, I'm running out of the battery. Thank you. We'll meet in the next class.